Hello. Hi guys. Am I audible? Am I audible? Hello.
Yes, we can hear.
Cool, cool. Okay, so week 9, week 10. Week 11 has been released, right? Any okay. Week 11 assignments have been released, right? So okay. So my plan from this week onwards was to basically revise the stuff which we have studied till now. And by revision I mean we can just go through all the basic things so that you can have a clear map of everything, because the last session calendar, today is 1st October, then we have on 6th October and 13th October. After that we have a bonus session, bonus live problem solving session on 20th October. Okay, so we have 4 sessions remaining, we have 8 hours remaining, and 8 hours are I think sufficient to start from scratch and just go through, brush up all the concepts a bit, so that you just get to know what all things we have studied. So what I'll do is, we have 10 chapters, we have 4 weeks, so we can just take two chapters a week, and then the last chapters are easy, and because you have studied those chapters recently, so they don't require that much brushing up. So yeah, let's start. My iPad is connected. Let me share my screen. So we can go week by week or chapter by chapter. So some chapters are big, so we can break them down. Anyways, let's start with chapter one. By the way, did you guys have any doubts till this week in any assignment? Sushma? Hello?
Yes, sir.
Any doubts in these week, like week 10 assignment?
You are talking about the 10th one?
Yeah.
Okay, 10th one is evaluation is not done tomorrow. So
Okay, okay.
I just have this. I don't want to answer, but just
Yeah, you can just
so
ask the doubt.
the last question, 10th question, negative samplings.
Hmm.
So negative samples are required to actually reduce the computation.
Correct.
So if all are positive, then
Then what is the
the
issue if all
computation.
are positive?
See, so it may not happen that all are positive, right? So
If that,
sample,
just consider a case that all are positive. For a second, just consider a case that all samples are positive. Okay. Then
so
what
in that
happens?
case, in that case, we need some negative sample to reduce the computation.
This is okay. Why?
And
Why?
suppose
Why?
all,
Why do we need to? How do we reduce the computation?
so that that supervisory algorithm can differentiate between positive and negative.
No, but how do they reduce this computation? Any idea? Okay, let me explain it. Okay, so in past lectures, I have taught about how graph machine learning works. Okay, so you have a graph, you feed all the edge for link prediction task basically. I'm explaining in this in the context of link prediction task. So for link prediction task, you take a link, you pass that link, I mean the both the nodes connecting the link in a model, and that gives an output. Okay. So during training, okay, let me I brought right on my iPad, and that will explain the answer automatically. Okay. So say during training, you have out of say 20 edges are there. So this means these 20 edges will serve as positive data, correct? But there are say 50 nodes, correct? So how many edges are possible between 50 nodes? 50 into 49 by 2, correct? Am I right, Sushma?
Right, right.
So what will be this number? 490 divided by 2, that is how much is this number? Compute. 49 into 50
Oh, 1225, sir.
divided by 2. 1225. Okay. So there are 1225 possible edges. Out of that, 20 are positive. So how many negative edges are possible? 1, 2, 2. Just a second. 1, 2, 2. Sorry, 1, 2, 0, 5. Okay. So if you want to train a machine learning model or any model to learn the difference between positive data and negative data, because all ML models ultimately create a boundary type of thing, or they basically maximize the separation between positive data and negative data. So your positive data will be these 20 samples, and your negative data will be these 1205 samples. So this means a lot of computation, correct? But what happens in sampling? In sampling, I take a fraction of this. That may be, say, that fraction may be almost proportional to this, or twice of this, or thrice of this. Anyways, it won't be as big as this thing. So this will be say 60 samples. So now, on what thing the computation has decreased? Positive samples or negative samples?
Negative samples.
Thereby your answer. Okay. Any other doubts? Hmm?
One second.
Sure.
So there was a question on the ninth week.
The week.
Question number 6. In a dynamic network, what can change with time t? So actually, my answer is correct, but I still have. I mean, there is some confusion. So answer was both nodes and vertices.
Correct.
So what I understand is node and vertices, they are same. They are interchangeable. So the I think it should have been nodes and edges, right?
Ah,
Because in that
typo,
dynamic
typo,
network,
typo.
everything changes.
Typo, this is
I
typo.
would,
Nodes and vertices are the same things, correct.
yeah.
It's a typo. Yeah, it should be nodes and edges, nodes and edges.
Yeah, because in dynamic
Got
network
it.
everything changes, including.
Obviously, nodes and vertices doesn't make their synonyms. This is typo. Okay. Rest everything was easy. Like week till week 8, there were a lot of doubts. From week 9 onwards, they like things not easy.
Yeah,
Anyways,
nine was okay, but
8 was difficult. Correct?
yeah.
8 was difficult.
Sir, do you have some question?
Sorry. Hello. Hello.
Yes. Sir,
What?
I was asking, do you have any questions from previous years?
Most of the questions from previous years are generally repeated. So, say like 60% questions are from previous years only. Okay. In exams as well, I don't think so. In exams, they will be repeated, but because I have not made any exam question and I don't have access to last year's exam questions as well, I have only assignments, and assignments are almost similar from last week, like from last year. A few questions change, or in say true, false, false becomes true, like that. So that remains almost similar. So that's why I'm taking these revision sessions. These revision sessions will ultimately help in just a second. These revision sessions will ultimately help you because you cannot revisit assignment because they are, if you get a doubt in assignment and then you have to go back and study. So in these sessions, like I will be just brushing up. I sent a message, didn't reach. Wait a second. Let me send it again. Yeah, message has been deleted. What's happening? I'm not able to post messages. Hold on a second. It should not have been deleted. I think I'm pasting some link because of that. Again, same thing is happening. Can you guys post now in anything in discussion group? Sushma, can you post anything in discussion group? Any new message?
Yeah, I'll try.
Yeah, please try. If you can post, just post that session is going on. Please join. I don't know what's happening. message has been deleted automatically. Are you able to post?
Yeah, yeah. I just sent one.
I posted inside another email, then it's going, and now it's deleted.
Yeah, I'm getting message has been deleted.
Yeah, what is happening? Where to raise complaint about this?
But under announcement, it is there.
Under announcement, it's there.
Yeah.
I'm not able to. How? Where?
On our course announcement.
Course announcement. You
So
got
it
my.
is. Yeah, yeah.
You got
So
my
it's
message.
saying date October 1st, Tuesday.
Who sent this? Who sent it?
NPTL team.
What time?
So it is sent today only.
What time exactly? Open the message. You will see time.
Time
Time on the
time
right.
time we can't see on announcement page. We can't see the time. It's only date.
No, no, no. I'm not able to see. That's what I'm asking. Na.
Okay, on announcement page we can't see the time, but I can see the
The,
date.
uh, what date? What is the message?
Social network analysis problem solving session reminder.
No, they that that's
Dear.
that's they have sent. I have not sent
Okay.
anything. Arey, shit.
Yeah. So the link to join is there. So
How can I? What the hell is going on?
are you not able to see the announcement page?
I am able to see, but I'm not able to message on that. Even that announcement is not visible on my page.
Yeah. Discussion form something went wrong.
Which something is happening. Message has been deleted instantaneously without even posting. The message has been deleted. Discussion forum message has been deleted. Group settings, posting policies. Wait a second, let me check. Who can see the group? Who can join the group? Who can post? Group owners. Who can view conversations? Member moderation. Who can modify? Who can contact? Group owners. Pub posting policies. Conversation history is on. Just a second. This is the only thing I hate. Like I'm just wasting time setting. Yeah, I got. No, yeah, I got your thank you there. I got that email.
Yeah. So only if you reply, it is.
My
Maybe
replies are also getting deleted.
maybe you can forward your previous email. Live session going on that
Okay, okay,
email.
okay. Let me try. Just hope it doesn't get deleted.
Maybe just Forward it
Live session is happening.
or reply all. Reply.
Forward to forward to announcement list. What is the email for announcement list?
I think because it's Tuesday,
So it does
many must have forgotten this.
it doesn't matter. It's like it's automatic. I generally post from here only. The emails which you get, I have forwarded it. Check if you got it. 23 approved conversations. What's happening? Just a second. Problem solving. People are. That's why people have not joined. I don't did. I can see announcement on NPTL page. I cannot see on Google Groups. I don't think so. People have got email. Yeah. Now, again deleted. Just sent it and just it got deleted. Anyways, we have live proof. I'm recording the lectures so I can ask NPTL team to review this stuff. Anyways, let's start. I'm not wasting any more time. Internet. Hello? Hello?
Yes, sir.
Uh, Let me try
You,
again. I think. Yeah, I got.
your messages now.
You got the message?
No.
Anyways, last attempt. I'm not wasting any more time on this. And then those people say people are not joining for session. Again deleted. Something is going on. Allow web posting, allow email posting, member privacy, create role. I need to check what they have done. Anyways, yeah, I got another email. Let's start with the revision. Are you there? Sushma, are you there?
Yes. Yes.
Okay, okay.
Yes, sir.
So I will start from beginning because I don't want to skip anything, and since a lot of theoretical questions are asked from these chapters, these starting and ending chapters, and so people generally mess up in these questions. So we'll start with that. Just stay with me, and we'll be discussing some of the interesting things from the book itself. I generally like discussing from the book because the content, I don't have to worry about creating something in content wise. Everything is given. Okay, so let me start with preliminary things. I'm not going into the depth of the applications, etc. Introduction. I'll just deal with the technical part. So, chapter 1. In chapter 1, we have some preliminary definitions. So a network or a graph is generally represented as G, V, comma E, where V are vertices while E are edges. Okay, this is quite common. And in book you can also see nodes. Vertices are also called as nodes and entities, while edges are also called as links and relations. So that question was somewhat incorrect. Somewhat, I mean, it was totally incorrect. So yeah, I'll report that and let's see if that gets removed from totaling. Then, how do you represent a network? This network. So you have say four nodes. Let me remove this edge. Okay, let me join this. So this is A, this is B, this is C, this is D. Am I audible?
Yes, sir.
Okay. So just the next concept is adjacency matrix. So adjacency matrix is represented generally used using A, and each of its entities, each of its matrix elements are referenced using ij. Okay, so ith row, jth column, it's like that. This is I, this is j. Okay, so generally an adjacency matrix is n cross n, where n is number of nodes, and when I draw it in this manner, so let me draw it: A, B, C, D, A, B, C, D. So now you tell me what should be the values given that there are no edge weights. Where what should be the value in A comma
Zero.
A comma B,
One. One.
A comma C 1, A
E
comma
one.
D 1,
D.
B comma A 1, B comma B 0, B comma C 1, B comma D 0, C comma A 1, C comma B 1, C comma D sorry, C comma C 0, C comma D 0, D comma A is 1, D comma this 0, this 0, this 0. Okay, so as you can see, this matrix is symmetrical. Okay, this matrix is symmetrical around diagonal. So for directed graph, it is symmetric, while for undirected, it's not symmetric. So now you tell me, it's symmetric, it's not symmetric. What relevance does it have? Being symmetric, being non-symmetric. Why does it matter to us that the matrix is symmetric and it's not symmetric? We could have just gone with the normal thing and we could have just been got it over with. Why does it matter?
So if it is symmetric, we know it is undirected graph because
Okay, I mean,
if we can go A to
if I
B,
already
then
know, if I already know that the graph is undirected, and I draw a symmetric matrix, so why am I drawing a symmetric matrix? Why am I repeating the values? What's the use of repeating these values? Okay,
okay, the complexity of
exactly.
finding.
So we are consuming a lot of space. Graphs are not 4 node graphs, there are billion node graphs. So instead of drawing adjacency matrix, the other data set in which these nodes are stored is adjacency list. Okay, so adjacency list is simple. Adjacency list is simple. I take node A, I take node B, C, D. What are the neighbors of A? B, C, D.
B, C,
Okay. What are the neighbors of B? A, C.
C, D.
Neighbors D also. No, it's not D. A and C only.
Yes.
Neighbors of C are A, B, and neighbors of D are only A. Is only A. So see here the it needed 16 blocks, and here 1, 2, 3, 4, 5, 6, 7, 8 plus 4. I mean these things we also have to store. You can see my pointer, right? This thing, hovering pointer. So we need only 12 blocks. So now is right now the difference looks only, it's only 4 blocks, doesn't matter now. So if you convert it to some bigger graphs now, so there's a drastic difference between this because it's exponentially increasing. This adjacency matrix is exponentially increasing in size based on number of nodes. Okay, I am not going to draw the adjacency matrix for directed graph. If you want me to, I can draw it. You want me to draw it?
No, sir.
Okay. Then yeah, that is all about adjacency matrix. Then we have types of networks. Okay. So uh, there are like a lot of networks are there. So let me just based on the views classification of networks. And let me remind you, like these questions will come in exam. These type of questions, links. What is the link centric view of a network? Then there'll be 4 options. You have to select if is it egocentric, ego network, or static or dynamic, etc., etc. Classification based on view. How a network is viewed. Basically, it tells what the network is. So first is link centric. Link centric means the links are of focus, are like importance. Versus if I do this. Okay, see what is the difference between this network and this network?
The other side is bipartite
Which one?
because among
This
them
one or this
they
one?
say
A
they don't have
or
access, but
B?
others
Which is bipartite?
B.
Okay, B is bipartite. A is unipartite. Unipartite means there was only one partition. If I do partition here, okay, all edges will be gone. But straight line partition. So basically, the concept of bipartite is if the graph can be divided in 2 parts such that there are nodes on each part which are not connected to themselves. So this is basically if I change a link like this, it becomes a unipartite. Okay, so if I change a link like this and then if I try to get this node here or anywhere, so say if I take this node here, so this node comes here. Okay, so this is joining here, but now this link has joined here, so ultimately it is become unipartite, and it cannot solve that problem of bi bipartition. Okay, okay, let me remove it. Other thing is if I put a sign on this, positive negative positive, positive, negative. So now this becomes a signed network, correct? Correct.
Yeah.
So basically, the links, I'm not changing any nodes, I'm just changing the links and checking if uh, I can change the properties of a network so that they can represent some entities like that. So basically, these are view based. So actually, you can basically you can take a huge network and you can derive a bipartite view out of it, a unipartite view out of it, a signed view out of it. You can create another view out of that graph without changing the topology of that network, only changing the properties of network, the edges and nodes. Okay.
Sir, I have a question.
Mm-hmm.
So where this sign network? I mean, is there any example for that?
Sign network. Mm,
Is it a circuit diagram or?
no, no, no. It's not related to circuit diagram. So you say you are playing some online multiplayer game. Okay. I have a huge data set of many of the games played in a multiplayer game. Okay, say I've taken Call of Duty or something. So a positive edge will only exist between teammates, while a negative edge will only exist between the rivals. So say some of the rivals have paired up in a game. So this can change. So say node this is node A, this is node B, this is node C, and they all matched up online. So this becomes friend this time, this becomes enemy. So basically network I mean the gaming companies, the softwares, they instead of storing the team data, they just store positive negative. Okay, with respect to you.
Okay.
So because they are respawning the characters, respawning in the sense what you see in front of your eyes doesn't mean that other rival is the graphics are rendered in that way. The graphics are rendered for that person independent of you. Okay, so the costume which you are wearing, sometimes it happens in games like you are wearing some costume but other players cannot see that costume. So that basically means if I have to store that data in a manner that the player spawning in front of me is my teammate or my enemy. So it might get a green circle on his head or a red circle depending if it's my enemy. Because if I store team 8, say this is team alpha, this is team beta. No, some C has some positive edge. This is team beta. Okay, so issue with this thing is that uh, now I when I am playing the game, okay, when I am playing the game, I have blue circle on my head, but opposition has Z circle. But opposition also playing the game as well, but they also have blue circle on their head, while they see red circle on our heads. So that cannot be created dynamically. Like if create my character, and if I see the circles are different, like circles are same for each other. Say I not same, different. Like I'm getting red, that person is getting blue, but that person is seeing that person got blue, but I got red. So that is not in case of games. In games, opposition means red, your teammate means blue. So these edges are basically used to determine the relationships between players and creating those costumes, circles, identification marks for friend versus foes. So that is the basic example of this thing. Okay, in online world, this is the basic example. Got it?
Yeah. So this is kind of weighted graph.
Not weighted, but I'm not weighing the friendship. I'm just giving some symbols over it.
Okay. It's just signing the edges. Okay.
Yes. There's a very small difference. If I give weight 0, weight 1, that also means weighted. But if weight 0 means you're my enemy, but weight 1 means you are my friend. But see, if I want to check if B is enemy of A, okay, but I know that game is running on C server. So what I'll do is I will multiply their signs. So plus into minus gives minus. So this means A is enemy of B. Okay. So that's why this sign is used. Because sign can be multiplied to know the nested friendships or enemyship, whatever it is. Got it?
Yeah.
So yeah, this is all about the signed networks. Now coming to other part. So this was link centric view. The other is node centric and link centric both. Just a second. Okay. Node centric and link centric both combined together. So right now we saw only link properties. If they are switched, what happens between the relationships? What happens if I change the node properties? Like I told you, the uniform, etc., etc., the character respond. Okay, so those properties are also different. Okay, so there are like two, three types of networks for that as well. One is homogeneous, other is heterogeneous. Then there is multidimensional, etc., etc. Okay, so homogeneous means all nodes have same properties. All nodes have same properties. I mean they are like key value pairs of properties, na key values. So the keys are same. Like dress blue, dress purple, like that. So keys are same. Values might be different based on the character. So that is a homogeneous network. Just a second. Got it?
Yes, sir. So there
So
was a question on week 10 also on this.
what question?
There are given options like in social network users, which is not actually the question was which is not homogeneous.
Let me check. What was the answer?
It was a second question on 10th week. Yeah, similar question.
What was the answer?
So I answered actors, movie and actor. I don't know. It is not evaluated yet.
So evaluation happens after the examines, right?
Tomorrow.
Okay. Week 10.
Yeah, week 10.
Question number?
2 S, first or second.
Okay, second. Okay. So you tell me like what is the
So in case of co-authors, like nodes are authors, like
yes,
both
correct.
are authors.
They have the same
And
properties. They are studying somewhere. They are doing something. Correct.
I mean, they are co-authors of the same book. Or,
Same papers.
and
I
the
mean
citation
they
is
are human beings. So overall properties will be similar. But
yeah,
actor movie network,
yeah.
uh,
This
it
is kind of
it is it is
bipartite.
bipartite, but it's not only the case. Like we are not told that it is an actor movie network where an actor cannot be related to another actor. You're getting my point?
But the movies like non-living things. It's like a
See,
company and product kind of.
if there are no edge weights, if I add edge weights, if I add edge weights to it, say some sign or some weights or some property. So edge, if edge is one, edge meaning is one, like edge has a weight one. This means it represents has actor played part in movie. If edge weight is two, this means it plays this is this actor uh, have these two actors acted together. So in that case, if I add like edges like this, then it becomes a heterogeneous network because the edges have different properties and the nodes also have different properties. So it is a node plus edge heterogeneous network, correct?
Yeah.
And any bipartite network is simply node heterogeneous network.
Correct.
It's not edge heterogeneous. It's node heterogeneous. Got it?
Yeah. Yes, sir.
Just a second. Yeah. So this is the like all things are almost similar. All things are almost similar, but it's just that ki what perspective you choose, what view you choose for a network. Okay, so if you choose bipartite view, then actor movie network is also bipartite. If you choose heterogeneous, then there are two possibilities. In bipartite case, there are say no heterogeneity is present. In this case, if I apply weights to edges, then it becomes edge heterogeneous. Sorry, node plus edge heterogeneous. Like a lot of possibilities are there. So you have to just use your intuition to think about the possibilities and then click the answer. So that's why I'm telling these possibilities. These starting two views are confusing. Then local view, temporal view, generalization. These are easy. Getting it?
Yeah. Yes.
Then coming to local view. So local view tells about neighborhood of a node. Correct? Correct.
Yes.
So what is just what is that thing? What is the how can you get the neighborhood? So if I take one node, if I start drawing something, they are connected. They are connected. Okay. So if I take this A node, so what is the neighborhood of A? B, C, D, E, F, G. Neighborhood of A is B, C, D, E. Right? Correct?
Yes, sir.
So if I so instead of representing it in kicks, because I know this thing is just one node thing, like one element thing, so I'll just create something like this. So that will be B, C, D, E. So this thing is ego network. Why is called ego network? Because this network sort of tells it's only about me. This network sort of tells something about a node. Uh, Say like it's only about me. I don't care about anyone else. So look at me and see what others think about me. Okay, about me, not they talk what they talk about me. I mean, we are not looking at these properties. What they think about me. So that can only be thought when we see this thing. So this node becomes ego node, and since like these nodes are the influential nodes that are influencing, so they are called alters. They are altering its view of itself. If I remove one node, then that ego gets broken of that node. So that's why they are called alters. They alter his ego, that node's ego. Okay. Uh, then coming to the next thing, we have temporal view. So temporal view, you have already seen like there's static network which remains static all the time. Then there's dynamic network. In dynamic network, nodes, edges, properties, in fact, they all can change. A network can become hetero to homo and homo to hetero, vice versa. A network can become unipartite to bipartite. Anything can happen. So basically, see, everything is linked just in sequential fashion. Okay, getting it?
Yes.
Okay, just a second. I'm getting something. Okay. So now we have seen this stuff, and now let's come to one important thing, that is hypergraph. Now, what happens is, as you can see, these properties, unipartite, bipartite, they have been around since centuries. Okay, like not centuries. Centuries ago, we started studying, but they have been around for quite a long time, and there has been a lot of research around them. But then there is hypergraph. So its research is flourishing right now. It means it has just started, and a lot of stuff is going on in hypergraph. So what is hypergraph? So right now there can be two nodes and one edge, two edge, three edge. Correct? This edge can mean they have acted together. This edge can mean they have acted together in the same year. This means they have acted together in a different year. Doesn't make sense, but just get the gist of it. So this means they are married together as well. This means they have kids or not. Okay, got it.
Yes, sir.
So two nodes can have multiple edges, but can an edge have multiple nodes? Is it possible? Let me just
So
do
in
it.
a graph,
I
it
have
can be only two nodes.
I have one edge. Okay, I added two nodes around it. What? How can you add more than two nodes? Can we do this? Doesn't make any sense, right? The edge is getting broken.
Yeah.
So what if I take now current right now my edge is in 2D plane. So in 2D plane it's a line, correct? In 2D plane it's a line. So what happens if we just move this edge to 3D plane and increase one dimension to it? So now this in 3D plane the edge will become a plane. In 2D plane it can also become a plane, but think about it can also become a plane. But think about in this perspective. So we just want to accommodate all the nodes in an edge. So that is only possible. That is only possible if see if I'm adding nodes here. This looks like the edge is getting broken. But if I just uh, create a plane in a 3D plane, 3D space. So if I tilt it, now you can see this whole thing is an edge. So I can place the nodes on this edge. Okay. So a planar edge, that this edge is a line. This is a planar edge. These four nodes belong to same edge. These three nodes belong to same edge. These nodes belong to same edge. Getting it? Got it? You see? It's like clustering the nodes as edges in edges. But we cannot
Okay.
basically cluster edges in nodes. Like we can, but doesn't make sense because nodes represent two things at a time. But edge till now edge used to represent a binary connection between two nodes, one and zero and one. But now it has turned on to some multi-dimensional thing. Okay, got it?
Yeah.
So this is in book you can see. It's basically multi-dimensional network is there. This is hypergraph you can see. So what is hypergraph? They are like edges are clustered like this only. Okay, so Lash is calling me. I don't know why. Just a second. Mm, just a second. Just a second. Okay, sorry about that. So then there's we have seen. So why did we divide in planes? Because now from planar edges we can create multidimensional networks. Okay. So say this edge contains a lot of nodes. Then there is this edge that contains a lot of nodes, and then you can create like this linear edges between them. Got it, Sushma?
Yeah, I was just thinking, what is the application of this
Application.
hypergraph?
Okay, let me tell you. So WhatsApp group. Okay, you
Okay.
are a member of some WhatsApp groups. I am a member of some WhatsApp groups. There might be a case that NPTL WhatsApp group and NPTL WhatsApp group we two are common. So we will be like this intersection. Oh, sorry, eraser. We will be like this intersection. Got it?
Yeah, it's kind of community on WhatsApp.
Not community. In community, the thing is, see,
Community, they have
I have
multiple
I have a
WhatsApp.
WhatsApp group. I have 20 members in it. Okay, they all are
Okay.
connected to each other. Does it make sense to create edges between all of them? Because they have the same relationship. They are a member of WhatsApp group, NPTL. Does it make sense to connect all of them with same edge? Does it make sense to create a complete graph? Because then graph will become huge. We will be having a very huge
Okay.
adjacency matrix.
Okay.
Okay, but if I
Okay.
create
The users may be a part of the multiple WhatsApp group.
yes, they can be part of multiple WhatsApp group, and that's why there is this intersection thing here. This intersection thing.
Okay. Yeah.
Okay,
Now
so
it makes sense.
yeah, and let me give you one more example. So say I take two WhatsApp groups, okay, and say there are 20 members in this and 30 members in this, and say this is women's. There's a society. There's this is a female WhatsApp group. This is a male WhatsApp group of male members. Okay, but now we can create edges between them. So this woman is wife of this man. This woman is wife of this man. Some men are single. Some women are single. So see, planar edges are there. Okay, linear edges are there. So this is a multi-dimensional graph.
Okay.
Got it? These things are
Yes. Yes.
important because they might not be asked in exam, but they are very important because in future when you are working somewhere in companies, it's always a better option to go for higher dimensional graphs. What's if I say there's a WhatsApp group and I want you to create a network X graph of that. Does what possible scenarios do you have? You can create a complete graph of that WhatsApp group, or you can create this hypergraph. So what will you choose? Hypergraph, obviously, because first thing, network X has libraries that can handle hypergraphs easily. Secondly, hypergraphs require lesser amount of space to store them. If I create a complete graph, then I have a complete matrix of 1 1 1 1. Doesn't make any sense. Useless matrix, correct? But somewhere I have to store the data, na? Somewhere I have to store the data. Got it?
Yes.
If even if I do neighborhood, so neighbor of A is every node, neighbor of B is every node. So adjacency list is also filling there. So everything is filling there. So that's why we create hypergraphs. So there is a intuitional saying that a graph which is more near to complete can be regarded as hypergraph just to ease out the computation. Got it? We say there's some I have some graph in which 20 people are there and they are almost connected to each other. Only 3 4 people are there like they have not connected to each other. So we just assume that we create an assumption that they are also connected, and we make it hypergraph so that whatever computations we want to plan on that graph becomes simpler. Got it?
Yes. Yes.
Cool. Okay, so this is about hypergraphs. Then the dynamic graphs is they are simple because hypergraphs are confusing for people. That's why I've taught it clearly. And then this egocentric, etc., etc., everything is over. Hypergraph is over. Then this thing is over. Historical development. Yeah, someone had a doubt in the start of the these sessions in week one itself or week two. There was a doubt. Three types of social network analysis. So, what are the three types of social network analysis? Do you know? Just a second. If you know, please tell. If you don't know, think about it. Sushma?
Yeah, microscopic,
Okay.
mesoscopic, and microscopic. That
Yes. So, there's micro, there's meso, there is macro. And as you can see, microscopic deals with node level stuff. Mesoscopic deals with community level stuff. And this deals with graph level stuff, whole graph. Okay, now I'll explain it one by one. So say I want to see what neighbors are, like a node has some 100 neighbors or say 200 neighbors or 5 neighbors. So they are used, this is used for ego centric analysis. Okay, ego centric in the sense, what properties are we trying to study out of that? Okay, so if I'm trying to study the node properties. So if a node is is a part of ego network, if a node, if a graph is forming if a node is forming star pattern, this is ego network, right? If a node is forming chain with other nodes, okay. If a node is forming this is three loop out something. Then if a node is forming box, etc., etc. If a node is forming semi click, if a node is forming click, okay. So these are micro level studies. They are not they are not meso. They, they're some part of that can be meso level. So if I take say this thing, this is ego network, right? Sushma, right?
right?
So if I say this thing, this network is ego network of node A, B, C. But if I look at from perspective of node C, so node C is a part of chain of AB, correct? But if I look at whole network at a once, so ABC form a chain. I can write it like this. So language changes the category of analysis. Okay, if it's micro, I will talk with respect to node. If it's meso, I will talk to with respect to uh, subgraph. But consider this is the only graph present. I don't have any other thing. Then this also becomes macro analysis because there is no other graph. I have to study the properties of this graph only. It's not a part of any other graph. It's just independent graph, which has been created by some independent study. So this becomes macro level, correct? Am I right?
Right, sir.
So yeah, this is meso macro stuff, and after that there is, anyways, this might one two mark questions might come around, like one two MCQs might come. So graph visualization tools. What tools are used for graph visualization? I've been teaching it from the start that there are some web-based tools, website-based. Then there are system-based tools like that. A lot of stuff. Standalone. We call them standalone tools. Just a second. I'm just waiting that somehow that message gets reverted from deleted and I get an email. So that's why I'm checking again and again. I don't think so that's happening. Okay. So web-based tools is I can open the website and I can just upload my edge list that can be in txt file. I have taught in starting sessions the coding part, that how edge list is represented in a txt file, CSV file. So you can revisit with week 1, week 2, week 3, somewhere there that video might be there. So I just upload that file online on these portals and they will create graphs, and then I can just try to detect communities from them, try to color, try to organize it in some visualization patterns. There are multiple visualization patterns as well. So we do that stuff with using web-based tools. But the problem with web-based tools is, let me write the names first. So one is this polynode. Okay, then there is node goat, linkage, Palladio, etc., etc. are there. So problem is, you have an 8 GB system computer. You started an operating system, okay, and when you started that operating system, that system consumed 4 GB or 3 GB out of that 8 GB. Now you are left with 5 GB. You opened your browser, Google Chrome. That browser opening consumed 2 GB RAM. Now you open this portal and you upload the data set of say 200 MB or 500 MB nodes, like billion images data set. So now what happens is this much big data set crashes that browser, because browsers windows are not meant to use. Sometimes you see this thing becomes slow. Stop this browser, stop this tab, your browser is becoming slow, like that. You have seen it, right? Sushma, hello.
Yes, sir.
So that is
So there
the
is some background noise, so
from
I'll
your
be
end.
on mute.
Okay, okay, okay. Stay on mute. So the problem with these web-based tools is they require significant amount of memory and they waste significant amount of memory. What's the use of Chrome consuming 2 GB and then network consuming 2 GB, etc., etc. So because there's operating system, there's another layer that runs Chrome, there's another layer that loads graph. So it's layered like this. Okay. So there are then standalone tools. Standalone tools, they directly interact with operating system. So instead of consuming 2 GB in the start and then loading data, they only consume say 200 MB. And now I have around 6 GB RAM or 5 GB RAM remaining. And I can load again 500 MB data, and that visualization will ultimately result my whole software consuming around 2 GB RAM after loading. And this in start was, in browsers generally start consuming more than 5 GB at a time. Okay, so that is why these standalone tools are needed. Standalone tools also, since they there's latency issue. So say you don't have internet right now, so you cannot run these web-based tools. But or say some feature is there, but that feature requires some high quality internet, high amount of internet to run. So in that case also, you can just let me plug my charger. In that case also, it becomes very difficult. It becomes very difficult to use those tools. So that's why I taught about Gephi. I taught about, there's one other tool. I don't know. This Gephi is important. GEPHI. This is a standalone tool for graph visualization, understanding, studying all the node properties, edge properties. It generates graphs as well, distribution plots as well, everything. So if you want to write a paper on a graph, you don't have to code. You just pass it, study the properties. Okay, give some survey about that. You can just write paper without writing a single line of code. Okay, so this is what Gephi does. This is what standalone things do. Softwares. Now coming to chapter 2. We have sufficient amount of time. We can finish it. I need to talk to NPTEL team before Friday. Okay. If you want to take a break of 5 minutes, you can take. You want to take a break?
No, sir. No, sir.
Okay. Let me take a break of 1 minute.
Yeah. Okay.
Just a second. हाँ बोलिए। हाँ हाँ। तो प्रूफ कौन मांग रहा था? क्या लिख के दो? क्या बकचोदी चल रही है ये? नहीं नहीं, तो इनको इनको दो पैसे की तमीज़ नहीं है कि कैसे किया जाता है। चलिए मैं जाता हूँ, तो मेरे पास 1 मिनट है, मैं जा रहा हूँ वापस। हाँ हाँ हाँ। ओके ओके। हेलो। हेलो। एम आई ऑडिबल?
Yes, sir.
ओके। So now till now we have studied a lot of stuff about graphs. So let's study some mathematical properties. Mathematical properties in the sense like what, how to create quantitative features. Those features that can be counted, that can be expressed as numbers, because that can be fed into computers. I cannot simply say that this is a link centric view, this is an egocentric view to a computer, and the computer can understand. I mean, right now the LLMs are there. LLMs, you can write it in language format, and LLMs can understand large language models. But I don't think so. Like the old traditional models, they can understand the language in that format. So yeah, that is that, and that's why these quantitative measures are created. So one quantitative measure is degree. You know the degree of a graph. So degree of basically nodes. So let me tell you for uh, both of the directed and undirected things. I will. Okay, so A, B, C, D, E. Now tell me the degrees of all nodes A, B, C, D, E. What is the
For A
degree of?
it is 2,
Okay,
B it is 4,
okay,
C it is 1, D it is 3, and E 2.
okay. So this is the degree. So if you see, if I try to start drawing the distribution, so nodes with degree 1 is 1, nodes with degree 2 are 2, nodes with degree 3 is 1, nodes with degree 4 is 1. So you can see something like this if I try to plot this graph. Got it?
Yes, sir.
So why do we need to study this graph? Because network science tells us there are very less nodes with high degree, but there can be a lot of, because this is not a very big graph, so that's why uh, lower degrees are also low, but generally the degrees follow this pattern, some power law pattern type of thing. So nodes with degree 1 are higher, nodes with degree 2 are lower, nodes with degree 3 are more lower, then nodes with degree 50 are ultimately lower, nodes with degree 200 are ultimately less, a lot lower than this. So this basically tells the degree distribution. Correct? Hello?
Yes, sir.
Yeah. So this is what degree distribution tells us about the graph. So if I, so these degrees are of a graph. Okay. So if I look at these degrees, I cannot make up anything about the graph. What I can tell is, I can tell a node B has degree 4, node C has degree 5. But if I convert this in this distribution format, then I can talk in respect to graph. So this node 4 has this much degree, node 5 has this much degree, node, sorry, 6 nodes, node the degrees 6 is present with these many nodes, These many nodes contain degree 4, 3, like that. So now we are talking with respect to graphs instead of nodes. So this is why these degree and degree distribution are important. Then there are some probabilistic properties, that stuff. So probability of having degree 1 is 1 by how many degrees are there? 6 degrees are counted. What is this? Now how many nodes
12.
are there? Nodes are
12.
4. No, how many nodes? Nodes. There
5.
are 5 nodes. Okay. Probability of having degree 2 is 2 by 5. Probability of having degree 3 is 1 by 5. Probability of having degree 4 is 1 by 5. Got it?
Yes.
So yeah, this is what degree stuff tells about things. Got it?
Yes.
About the graph basically. So we're talking with respect to graphs first now, because we want to study the properties of graphs. We go with degree distribution. If we don't want to study that, because the node level property is lost here. We cannot tell which node has how much degrees. We can tell how many nodes have what degrees. Okay. So then this becomes a graphical issue, graph issue. So I can compare two distributions and check that if those two distributions are same or not. Okay. So basically that's how the graphs are checked, if they are similar or not. If I take two graphs, if I take WhatsApp graph and Telegram graph, if this degree distribution chart is almost similar, if I take one graph this and this other graph, if I subtract it, it should come a straight line closer to zero. It should not be very high. Okay, there should be a straight line closer to zero, or something like this zigzag line closer to zero. This is what we expect to check if a graph is similar or not. Getting my point?
Yes, sir.
So this is what power law distribution is. This is what is being taught in the three laws of Barabasi-Albert model, etc., etc. Then there are paths. Let me tell you two, three things about these path length, etc., etc. Okay, so what is a path? A path is edges between nodes. You cannot leave out an edge without a node, correct? You have to connect node. So if I take this graph, so anything from this node to some other node is a path. Okay, adjacence. Now, so basically, sequence of nodes that are connected is called path. So we'll study the different types of paths. We'll study different types of stuff here. So first, let us study adjacent nodes. Adjacent nodes are those nodes if they are linked by linked by an edge. Okay, so node A comma B are adjacent if the edge is present between them is E1, EK. Okay, incident edges, if are those edges if they have some common node, like say these two edges are incident edges because they land on a common node. Okay, getting it?
Yes, sir.
Then there is walk. So what is a walk? Walk is uh, say walk in a network. Walk is basically a sequence from some node A to some node B, where B can be equal to A again, such that the nodes between them, they are joined by, they are adjacent. These nodes are adjacent. So say I can take a walk of A, B, C, D. I can take A, B, C, A, C, B. Okay, so nodes can be repeated any number of times. So this is what a walk is. And walk length is the number of edges. So 1, 2, 3, 4, 4 is the walk length. Then there is trail. So trail means no edges are repeated. So see, ABC is there, then CA is there, then
Mm.
CB is there. So right now there is oh no edge repeated. So this is not a trail. Okay, I'm going A to B, B to C, C to A. Okay, then A to C again, then C to B and B to A. I'm going in reverse path. I'm not repeating it. So this means the edge is not getting repeated. Anyways, the nodes are same. Okay, so this is trail. Now what is a path? A path is a walk in which no nodes are repeated. So you can see the stark difference between them. Correct?
Yes.
Then what is a cycle? A cycle is a walk where start node, where a cycle is a path, not a walk basically. A cycle is a path where start node and end node are same. Am I audible?
Yes, sir.
Somewhat my internet broke in between. Okay. So then there's a lot of stuff about mm, examples given in the book. Those examples have also been discussed in videos. Okay. So just a second, let me switch on my phone. Okay, now there's distance. There's a new metric because till now what we have seen they are qualitative measures. Qualitative, like we cannot feed a computer this is a walk, this is a path. What we can feed a computer is this is the walk length. So that is not a qualitative measure because the walk length changes a lot. So now let's study some measures like distance. So distance is basically number of edges between shortest path. Sorry, number of edges in shortest path between two nodes. So say there are nodes A comma B. It has shortest path A, B, C, D. Sorry, A, C, D, A, C, D, B. Sorry, A, C, D, E, B. So now distance is 1, 2, 3, 4. Okay, distance is 4 here. Then we go to diameter. So now diameter is very interesting concept, and there might be a question or two on diameter of a graph. Okay, diameter of a graph, because now distance is computed between two nodes, but diameter is computed for a graph. Got it?
Yes.
So diameter is the length of longest of all shortest paths. Okay, so assume you have five nodes. So you compute distances between those five nodes. So A to B, B to C, C to D, sorry, C to D, D to E, E to A. These are distances. They are shortest. Like A to B was 4. This is 3. This is 2. This is 3. This is 1. So now diameter of this will be 4 because the largest distance here is 4. So don't confuse between definitions. The longest of shortest, etc., etc. The length of largest distance between nodes in a graph is the diameter of graph. Okay, got it?
Yes, sir.
Then there is average path length. So can you tell me what is an average? What is this average path length? Hello.
So all average of all the edges between two
Average of
nodes.
all the edges. What edges? Like
Average of path length between two edges.
between two nodes or edges.
Uh, it's a node.
So see what I have done here. I have computed the distance between all the nodes. Now if I average it, this becomes average path length.
So it is a path length of between pair of
Average
nodes.
path length is also for a graph. Okay. Average path length is represented as IG. IG means G means it's for this property is for a graph. It's not for an edge for a node. Okay. So you want to compute average path length means what is the shortest, like what is the average shortest path. Okay. So if you compute like 4, 3, 2, 3, this is 4, 3, 7, 2, 9, 3, 12, 1, 13. So 13 by number of nodes, number 2 times number of edges. This is divided by 2 times number of edges. Okay. So number of edges means number of possible edges. Number of possible edges. This is E max. E max is n minus 1 by 2 thing. So what you do is you simply do n minus 1 1 upon n minus 1 summation of dij. This is what you do. Okay. These are the number of possible relationships from A to B, B to A to B, B to A. So that's why we have taken both of them. If you think about it intuitively, how many nodes edges are possible from A to B, from A? Then if you start taking B, then backward edges are also counted. Those already have been counted. So that is why we take this thing. We want to take the maximum possibility. What how many edges can be present? Okay.
And divide by 2 is because
This
edges between
this is
two
divided
nodes.
by 2 because we this Emax is represented in terms of nodes. We want to check how many maximum edges are possible, and since this is a undirected graph, so each edge represents two things. A to B is also representing B to A. Okay, because path from A to B has been taken, but B to A path is
Yeah,
also same. You also take this thing here as well.
yeah.
This is also 4, so that's why you divide by 2. We are taking both of the paths. A to B you have taken, B to A you also take. I just wrote it simply, so this will be not 14, this will be 28 by 2 into Emax, like this. Okay? Okay? Hello?
Yes, sir. Yes. I'm here.
Cool. This is very important chapter, like this chapter creates the basics of everything. Okay, then let's study about density of a network. So density is also computed for a network, for a graph, not for an edge, for a node. So density is number of edges upon number of possible edges. That looks simple. Getting my point?
Yes, sir.
So that I told you in start what fraction is taken. So this fraction is chosen based on density. What fraction is taken to consider if I can take this near to complete graph and make it a hypergraph. So that is basically chosen. So if this threshold is greater than say 0.95, you can just convert your normal graph to hypergraph. Getting my point? Hello?
Yes, sir. Yes.
Okay. Now then there is clustering coefficient. These concepts are very basic, yet they are used till the last of the chapter. Okay. Then there is clustering coefficient. So there are two types of clustering coefficient: local clustering coefficient and global clustering coefficient. Can you tell me the difference between local clustering coefficient and global clustering coefficient? Basic difference. Not going into technicality. What does each represent?
So local means about the neighbors.
Correct. And global means?
Uh, in entire network.
Not per se. So local, what do you mean by local? You mean some local neighborhood of somewhere. And global means complete graph, okay? So local clustering coefficient is always computed for a node, while global clustering coefficient is always computed for a graph. Okay. So this is basically computed number of edges between neighbors. I'll tell you an example of node vi divided by possible edges between neighbors. ठीक है? Okay, so see, I have this graph here. Let me take smaller one. Okay, so see, if I convert this to this sort of thing, so now you can see now
Yeah.
this sort of,
Only there are two edges between the neighbors.
yeah. So if I want to study this graph, what I'll do, for this node I will remove these edges. I will remove these edges here, and now you can see. So ci will be 2 upon,
Two.
how many edges are possible in this 4 node graph?
Four
N
C2.
into n minus 1 by 2. This will be 2 upon 4 into 3 by 2. So this is 2. This will be 2 by 6. This will be 1 by 3. So local clustering coefficient is 0.33. Correct?
Yes, sir.
Got it?
Yes, sir.
So if you want to do for bigger graph, you can just simply use this formula. You can simply use this intuition. I will redraw this. Then there is global clustering coefficient. Okay. Global clustering coefficient basically talks in the terms of triplets. Since it is computed for a graph, G is computed for a graph, so it says number of closed triplets in graph divided by number of triplets. Okay. So consider I take this graph here. Consider I get this graph here. Okay. Hello.
Yes, yes. So closed triplet is one.
So you can see if I take 1, 2, 3, this is a closed triplet. If I take 2, 1, 4, 4, 1, 3, these are open triplets. So there are 2 open triplets, 1 closed triplet, right?
Yes.
Is there anything else? 3, nothing, right? So the answer will be 1 by 2. Okay. So no. GCC, it's 2.6, okay. 2.6 C. There is given 3 closed triplets. Notes 1, 2. Acha, okay, there will be 3 closed triplets. So 1, 2, 3 is there, then 2, 3, 1 is there, okay? And then 1, 3, 2 is there, okay? So there will be 3 closed triplets, okay?
Okay.
Then there are these 2 open triplets plus 3 closed triplets. Total triplets are, then again this 3 plus open 2. So this will be 3 by 5, okay? Because you can take only 2, 1, 4, but you cannot take 4, 1, 2 because 2, 1, 4 has already been taken. If I take 1, 2, 3, I cannot take 3, 2, 1. I will take 3, 1, 2, okay, and 2, 1, 3, okay. So that is why these 3 are there, but these 2 are there. They are not like 4 or 5 or 6, okay. Got it?
Yes, sir.
Then let's talk about connected components. This is very important. I am just revising it, but I have discussed it in detail in one of the videos. I think you are present or not? You are present in that week. Hello.
Yes, sir.
So connected component means what fraction of graph is connected. So if I take this graph, this is a connected graph, okay. But if I take one something like this is becomes a disconnected graph. It has two parts, so it has two connected components, one and two, okay. So now what is a what bigger component can you see here? You can see this is a bigger component visually. This is a smaller component. So generally smaller components relate to noise. So that's why it is important to determine bigger component, larger components. Okay. So large connected component we have to find. Okay. So that is what connected component in a graph means. Okay. So connected component generally means can you go from one node to another node. So I can go from this node to this node, go from this node to this node, go from this node to this node anytime. But I cannot go from this node to this node. I cannot go. Okay. So that is why it is not connected components. These components are not connected. Okay. But what happens in case of directed graphs? I can go from this node to this node, this node to this node. But can I go from this node to this node? I cannot. I cannot go from here. I cannot go from here. I cannot. The path is in opposite direction. Okay. So this is not a connected graph, but this terminology is not is used in directed graphs. The alternate terminology we use is strongly and weakly connected. So if I remove these signs from here, these signs, it becomes a weakly connected graph. Don't remove it. If you can go from this node to this node, disregarding the sign, then this is a weakly connected graph. But if you could have gone from this node to this node, considering the sign, then it was strongly connected graph. Okay, or component, or I can take like this. So I can go from this node to this node, this node to this node, anything I can go. So this is a strongly connected component, this is a weakly connected component of the same graph. Okay, got it? But they are not connected. So these are two different components. This is strong connected, is strong, this is weak component. Okay, got it?
Yes, sir.
Cool. Then there are centrality measures. Centrality measures. Just a second. Still, I'm not getting an email. Okay. So, what different types of centralities are there? Can you tell?
Yeah, so degree centrality,
Okay.
closeness,
Degree, closeness. Then
betweenness centrality.
betweenness. Then I've written E. What centrality can be represented using E?
Eigenvector.
Eigenvector centrality. Then there is CATS centrality. There's page rank. Okay. Then there is hub and authority. A lot of stuff is there, and this is I cannot discuss all of it today. Okay, so just I'm writing the names of these things, and I'll discuss it in next session. I'll complete it. But anyways, I'll start with degree centrality and stuff. Okay. So what do you mean by degree centrality?
So it is a node's degree.
It measures connectedness. Okay. It measures how much of the network is connected. So it is again basically degree centrality. These are node measures. Okay. So degree centrality of a node is basically degree of that node divided by maximum possible degree in the set on that graph. Okay, so this U can be any node in that graph. V is the number of vertices from this G V comma E. Okay, so this is what the maximum centrality measure, maximum thing which you get. So for say this graph, for this graph, this node has degree 2, but the highest degree is degree 3. So degree centrality of this node is 0.66, while degree centrality of this node is 1. This means this node is the best possibly connected node in the graph. Okay, and this is 66% connected to the best possible node in the graph compared to the best possible node in the graph. Okay, got it?
Yes, sir.
Then we have closeness centrality. This centrality measures how close the node is from the rest of the network. How close the node is from the rest of the network. Getting it?
Mm.
How close can the node be? Okay, so let us consider I'm not going into the depth of it because it's already given in the video if you want to study, but I will just write it down like this. So you take, okay, you take a node U, you take a node V. For this node we're going to compute. So this node U belongs to vocabulary, whole of the graph. Okay, and U is not equals to V. Okay, so now what you do, from this node you compute distance from all other nodes, and if I want to take the average, so that number will be quite high in the sense, say if the node is very far from all the nodes, this number will be quite high. Okay, but it does it reflect that centrality thing, because the node is moving away from the centrality part, right? Right, am I right?
Yes, yes, sir.
So that is why we invert it, we bring this below. Instead of writing it in this form, summation upon v by 1, we write it in this form. In this manner what happens is, this number gets converted to some intuitive number, fractional number, which can be used to interpret how much closer 66%, 70%, 30%, like that. Okay, so we invert it, and we take this thing as numerator because we want to normalize it. We normalize it within the range of 0 and 1. Okay, so this is how we get the closeness centrality of the of a node. Then you want to study between the centrality, that uh, you can study. I won't right now I won't teach because it will take a lot of time. So what I'll do is, we can continue this all stuff from here itself in the next class. Okay,
Yeah,
so please be present in this session on Sunday. Last Sunday I was ill, I could not take, and that is why there are very less people. They cannot make up for that schedule. Like, it's my error from my end. I should have taken, but I was not in condition to take at any time. Like, I was lying down all the time. I was not able to wake up at all. So today also I'm not completely fine. I'm just weak, a bit weak. That's why I'm speaking a bit slow today.
no problems.
Anyways, so yeah, this is all for today. So you have any doubts or any doubts regarding exam, anything?
Yeah, maybe we can take it in next class.
No, no,
So
no. Please, we can
between this,
5 minutes we can talk. Like, I don't want to teach because this is a long concept from further on, but I can discuss a bit basic doubts about, like, whatever doubts you have.
okay. So this is about that question I got it wrong
Which one?
from that quiz. The spy in the network.
Yeah, I told now already. I think. Just let me check.
Yeah, yeah.
So
So I keep
which one?
that concept is not very clear
Which
because
week was that?
we thought that the spy in the network, they want to spread the news. So between its centrality is like a bridge between the two graph.
Which week? Week 2 or week 3?
Uh, week two.
Okay.
So my thinking was that if the bridge is broken, I mean between its centralities,
Uh huh.
then the information cannot be spread. Like
Correct.
if this bomb the bridge or something. So I did not answer that between centrality.
Okay. So
So the answer,
what is the
so
doubt?
yeah, it was actually closeness centrality.
Closeness? What closeness?
The answer is the question was you are a spy inside a terrorist organization with
Uh-huh.
extensive knowledge of social network analysis. Which centrality measure you will use to find a person who can spread a message as far as possible in the network?
Okay.
So answer was betweenness centrality.
Yes.
So I thought that it is
Closeness
closeness
centrality.
centrality.
It looks like that. See, the thing is, the node which is closer to all nodes doesn't mean it will spread the information. This means the node is closer to most of the nodes, but it's not connected to farther ends of the node. Okay,
Okay.
it is closer to most of the nodes, but it does not connect the farther nodes. Okay, this basically means you it can spread the information to its neighbors completely. Okay, in its neighborhood, it will completely disseminate the information, but it will not reach to the farther ends because other nodes are not close based on closeness centrality, right?
Because
That
he cannot closeness centrality cannot spread the news faster. I
yeah,
mean,
it
it is
it can it can basically spread it like it can diffuse it like this, and then it will stop because the other nodes don't have that much high closeness centrality. But if I choose a node with high between centrality, this means it is connected to the farther ends of the graph. So it will basically spread the news to farther ends, to smaller ends, whatever it want. Okay, based on that itself, it acts as a bridge
yeah.
like
So
spider.
betweenness centrality was correct because it
Yes,
can spread the news both side
yes,
faster.
yes. Because the nodes which are closer to each other, obviously they have high closeness centrality, correct? But that doesn't mean that the news will flow to the higher ends, the back of the graph. So that is why
Yeah.
between the centrality is the correct answer because it's important to
But
spread the.
I thought that that person get captured by enemy, then
That
he
that
will
is
not
the,
be able
that
to.
yeah, that is the issue, na. If that person gets captured, the information will not spread at all.
Hmm. So
Okay.
in that case, like for the message spreading faster, uh, betweenness centrality is correct answer.
Yeah.
But
For a message
if
to reach to higher number of people, closeness centrality is correct.
yeah, correct.
Got it?
Yeah, higher number of, but maybe it will take time.
It
But
will take time to reach to the end of the graph, but the initial diffusion will be higher.
hmm, correct.
Okay. Then it will based on other similarity measures they will diffuse it, whatever they have in their Pandora box. I don't know, but yeah, this is the gist of it. Any other doubt?
No, yeah, the fifth chapter was little difficult. Maybe when we
Fifth
come next week
chapter.
to
We will
fifth one.
discuss it on next to next week.
Okay.
This means
Okay.
this. Let me check the calendar. Yeah, on 13th we'll discuss it. 13th of October.
Okay.
Fifth chapter, I agree it's difficult. It's not difficult. It has a lot of concepts. So that is why it looks difficult. But
And then the quizzes which we get, only the 10 quizzes are there. So it doesn't cover entire chapter. Like chapter 1 to it is covering almost and the concepts are very clear with that subject.
obviously,
But
like these assignments cannot cover everything
yeah.
taught in the chapter, and it's not easy to make questions on everything which is present in the chapters. Because we have to make simpler questions for you to understand. For some concepts, it's questions become very difficult. So for say page rank, for Luvan community detection, for permanence, etc., the questions become very difficult. So, so
So
ultimately,
if
what
we get maybe more assignment, then maybe
more assignment
if not,
than that we have to talk to NPTEL team.
okay.
Can they include two assignments per week like that? Two
So
assignments with
it's like
different
we get
concepts.
120 questions for 12 weeks,
Then you will
which is
get
not sufficient.
you will get 240 questions then if there are two assignments per week.
Yeah.
So one assignment shall be released on Wednesday or one assignment shall be released on Sunday, Thursday, Sunday like that. So in that manner we can do. So
So
first,
it is planned for the next
no, no, no.
session.
I don't know.
Okay.
We need to talk to the NPTEL team. Right now, I even don't know how to communicate the message channel, discussion forum. Everything is logged right now. So I need to talk
For
to our.
every like we have
You are
four
able
five videos.
you are able to communicate.
Video.
I am not able to communicate. If someone is asking query, I cannot answer it because the message will get deleted.
Okay.
So I don't know why this is happening. Anyways, uh, let's wind up for today and let's
Yeah.
meet next week. I mean next this Sunday. Okay.
Yeah.
Cool. Then bye bye.
Yeah. Take care.